Welcome to Summarize Science. Today, we are looking at how researchers are teaching robots to handle complex, multi-step chores that used to be impossible for them. The problem with most current robots is that they struggle with long-horizon tasks, which are chores that require many steps in a specific order. A robot might be great at picking up a single toy, but if you ask it to clean a whole room, small mistakes eventually lead to total failure. To solve this, a team developed LoHo-Manip, a framework that splits the robot's brain into two distinct parts. There is a high-level manager that handles the thinking and a low-level executor that handles the muscles. The real secret to this system is something called trace conditioning. Instead of just giving the robot a text instruction like, "Put the mango on the plate," the manager actually draws a visual path on the camera feed. Think of it like a GPS roadmap for the robot's hand. By following this 2D line drawn over the real world, the robot knows exactly where to move and what object to approach next. This approach creates a closed loop, which means the robot is constantly checking its work. If it fails to grab an item, the manager sees the mistake and simply draws a new path to try again, rather than giving up. They train the system using a specialized data pipeline that turns videos of successful tasks into these visual traces. This helps the robot understand the intent behind a movement rather than just memorizing a specific action. One of the biggest advantages is that the robot can now work with objects it has never seen before. As long as the high-level brain can identify the object and point to it, the robot can follow the line to interact with it. In testing, this method outperformed many existing AI models, including some of the most advanced systems from major tech companies. It achieved a 97.5% average success rate on foundational skills tests in simulation. When they tested it on a real-world robot arm, it successfully completed tasks like sorting food and bottles onto different plates and containers. It even handled distractor items that were placed there just to confuse it. The system can even interpret abstract commands, like figuring out that adding a smoky element to a meal means it needs to find the barbecue sauce. This shows a level of common sense reasoning that previous robots lacked. To recap, the researchers have shown that breaking big tasks into visual roadmaps makes robots much more reliable and flexible. In the future, this could be the key to household robots that can truly understand and navigate our messy, unpredictable lives. This move away from rigid programming toward visual guidance is a huge step for the field. Thanks for watching Summarize Science, and we'll see you in the next breakthrough.